All right, we're ready to move on to our test for proportions. As we get started here, we're working with proportions. Number one, we're going to use a z-test. That z-test comes from table E, or our z-scores, hence the name z-test. With our z-test or our z-scores, we can use either the traditional method or the p-value method, and we'll probably illustrate one of each here as we go through. One little other side note here is that n times p and n times q have to be greater than or equal to 5 in order to use a normal distribution for this particular test. Again, we've discussed that back in chapter 7, so it should not be a big deal here. Our test score formula here is p hat, so insert a hat into your notes if you don't already have that. So our sample proportion minus our population proportion divided by the square root of p times q divided by the square root of n, noting that entire quotient, that calculation is all underneath that same radical. Bottom line here is we're back to using table E for our proportion, so anytime we're doing a test for a proportion, we're going to use table E, or our normal distribution. The only other real change besides going back to table E is our test score calculation, and then also a cosmetic change in step number 1. We write our hypotheses with a proportion symbol as opposed to a mean symbol that we've been working with for the last couple of sections here as we've gone through. So let's jump right into an example here. An educator estimates the dropout rate for seniors at high schools in Ohio is 15%. Last year, 38 seniors from a random sample of 200 Ohio seniors withdrew. At alpha equals 0.05, is there enough evidence to reject the educator's claim? So notice we don't see the word proportion, but 38 out of a sample of 200. 38 out of 200 is our proportion, or 0.19. That would be our sample proportion, so we'll come back to that. And then you can also see the percentage written right here, which is our population proportion. So notice here in step number 1, proportion symbol of 0.15. An alternative, also proportion of 0.15. He says that it is 15%, so we're equal to and not equal to. And our educator claims that it is 15%, so over here our null is our claim. In step number 2, I'm going to note that it's a two-tailed test. That alpha equals 0.05. We'll go ahead and do the traditional method with this one. So as I draw my curve, or a semblance of a curve, I have two tails, one on each side. If alpha is 0.05, then we have 0.025 in each side, and we'll use that to come up with our critical value. So I go back to table E. I'm going to find the decimal value closest to 0.0250. We have one right on top of it. That number is 1.96. So my critical value is negative 1.96 and positive 1.96. Moving on to step number 3, you can see I already have illustrated up here our sample proportion. So our test score is p hat, which is 0.19, minus our population proportion, which is 0.15, divided by the square root of 0.15. Its complement at n is 0.85. Remember, q is 1 minus p, and our sample size is 200. Noting that entire set of information is underneath the same radical, that gets me a test score of 1.58. If we bring 1.58 as a positive number up here, it's going to lie in our unshaded area, which tells me in step number 4 to do not reject the null. And in step number 5, we did not reject the null, so we said this was true, which means the claim is then also true. So there is enough evidence to support the claim. Or if we answer the question, there is not enough evidence to reject the claim. Those last two steps should be getting very, very familiar to us by now. But once again, I'll point out as we move from one type of problem to another, we have this basic change here in steps 2 and 3. Everything else kind of remains the same. although we did have this cosmetic change right here because we're working proportions instead of mean. We'll move on to another example of that then. College professor feels that females are doing much better in a certain math class in the population. College has a 52% passing rate in that particular course. If 16 out of 27 females pass the test, is the proportion of females that passed higher than the proportion of the population that passed test at the 0.01 level? So right away we have our dead giveaway that we're working with proportions. Our population proportion is 52%. He thinks the females are doing much better, so they're better than, higher than 52, which is less than or equal to, and since he feels or claims that they're higher than 52%, there's our 0.52, or alternative as our claim. So here we have a right-tailed test. Alpha is 0.01. So on our curve here, 0.01 is this shaded area out here, which means from here down is 0.9900. So we'll go to our table and find 0.9900. And that number closest to is, oh, where am I at? 0.9901. That would be 2.33. So our critical value is 2.33. Step number 3, we'll do our test score. Our sample proportion, I'm going to put over here to the side, is 16 out of 27, and that number is 0.5926. Now we don't want to round that unless we absolutely positively have to, so notice I went out at least 4 decimal places. Sample proportion 0.5926 minus our population proportion of 0.52. All sample or our radical 0.52. The complement of that is 0.48, and our sample size was 27. If I calculate that z-score, I get a z-score of 0.76. 0.76 coming up here is going to be in my unshaded area. So as I continue to move down here, hopefully I have enough room. I don't, so I'm going to put it over here. In step number 4, we once again do not reject the null. But in this case, because we're saying this is true, we're saying the alternative is false, which means the claim is also false, so there is not enough evidence to support the claim. Okay, so make sure you keep that alternative or that null hypothesis statement separate from the claim statement, and take a peek at where the claim is before you make that generalized statement. One more time here with our proportions. Salesperson claims that 40% of the people that come into the store make a purchase. To test this claim, the store manager selected a sample of 100 people in the store and found that 37 made a purchase. At the 0.01 level, is the salesperson's claim correct? I think just for illustrative purposes, we'll go ahead and use the p-value method on this one, just so we get back used to seeing that. So our proportion, 40% tells us we're working with proportions here. At 0.4, our alternative is also based on a proportion of 0.4. Claims that 40% that people come in the store make a purchase, so we're equal to and not equal to, and he claims that 40% do make a purchase, so here's our claim. Step number 2, we have a two-tailed test. Alpha equals 0.01. Since we're using the p-value method, illustrate 2 different ideas here probably. With the shade on each side is 0.005. We don't need our z-scores for this since we're using the p-value method, so I'm not going to go to the table to look that up just yet. I'm going to move on to step number 3. Our sample proportion is the 37 out of 100 that made a purchase, or 0.37. So it's 0.37 minus 0.40 over the square root of 0.4, complement 0.6, and we have 100 people in our survey. That is a test score of negative 0.61. So here's where the p-value changes things. We go to our table and look up negative 0.61. Negative 0.61 is 0.2709. Okay, since that's a left side score, that 0.2709 is the area to the left of here. So to get our p-value, I have a two-tailed test, I have to double that, so my p-value is actually 0.5418. Now if you recall back to our p-value lesson, I gave you two options. We can memorize the criteria. If the p-value is greater than our alpha in this case 0.01, which our p-value is, that tells us to not reject the null. So do not reject the null. Now if we didn't memorize those criteria, the easier way, at least in my opinion, is notice I've shaded the 0.005. I'm going to shade the p-value before I doubled it, so 2.2709 is going to shade way out this way because it's so much larger area, and you can see my cutoff comes where the graph was previously unshaded, and by now hopefully picked up unshaded means to not reject the null, and that will lead us to step number 5. Since we did not reject the null, we're saying the null is true, which means then the claim is also true, so there is enough evidence to support our claim. And there is a look at our proportions. I mixed in a p-value method problem just as a review of that method because we will see that pop up again.